started. My name's Chuck, and I want to welcome all of you to the multi-level security demonstration affiliated with the Open Group, where today I can say without hesitation that you will see history in the making. Why? Because today, for the first time, 4 of our nation's top defense suppliers, Boeing, Lockheed Martin, Raytheon, and Rockwell Collins, directly across the aisle over here, are collaborating to create the world's first demonstration of multi-vendor, multi-level security communications using an architecture called MILS. MILS stands for Multiple Independent Levels of Security. This architecture makes the deployment of multi-level capable systems more practical, achievable, and affordable. And today, the purpose of our demonstration is to prove that MILS is ready for action. What we're going to demonstrate today is a wide range of systems transmitting and receiving a series of data link message sets in a variety of security configurations and classifications. Now, in the past, this would all require an unwieldy number of communications platforms. But today, you're going to see a variety of systems all based upon the MILS open architecture. And to put our demo into a context, we're going to simulate 4 basic missions that all serve one ultimate purpose, and that's to rescue a downed airman. And what you're going to see are some of the ways that MILS can help enable secure communications within and between systems in the larger global information grid, the GIG. So, let's get moving with our first mission, sensing and targeting an enemy SAM site. This mission is what is typically referred to as a CD. And as we execute this mission, please take a look at the screen right over here, the Common Operations picture, the COP. For viewers in the Rockwell Collins booth over here, they'll be able to follow this demonstration on both the COP screen and a screen designated for the Combined Air Operations Center, the CAOC. Okay, let's check in with the big 4. Boeing, are you guys ready? Lockheed Martin, ready? Raytheon, you ready? Rockwell Collins, you ready? All right, Mark, they're ready, so let's do it. In this scenario, the SAM site is an SA-10, and the site's radar picks up our Global Hawk UAV. To ensure a safe rescue effort, that SAM site has got to go. Next, as you'll see right up here, the RC-135 rivet joint airplane has detected the SAM site's RF information and processes it. It also identifies the SAM site's 3-dimensional coordinates and sends that targeting information to the CAOC over top-secret information channels. Now, if we were using traditional technologies, these messages would stay in the CAOC in the top-secret domain. But our MILS-based systems enable a subclass of this information that can be shared with lower levels of clearance. So this MILS technology changes the game regarding the efficiency and distribution of information in the battlefield. The next step, secret information about the position of the SAM site and its RF capabilities is passed from the CAOC to the Global Hawk and to the F-18, which then confirms with the armed UCAV responsible for the destruction of that site. The CAOC directs Global Hawk to photograph the SAM site. The Global Hawk Wilcos snaps the images and then transmits those images into the CAOC. The CAOC gives the F-18 the go-ahead, and the F-18 executes its jamming mission. The SAM site is jammed, and shortly thereafter, the UCAV gets the go-ahead to do what it does best, and the SAM site's gone. To complete its mission, the UCAV sends its HAVCO to the F-18, which then forwards the message back to the CAOC. Finally, after the destruction of the SAM site, the Global Hawk flies in, takes a picture, and sends out the BDA to the CAOC. Bottom line, this mission was coordinated by single-level messages that were transferred from the UCAV through the F-18, the F-18 to the CAOC, and the CAOC back to the UCAV. Using traditional technologies, the quantity and the speed of this information would be much less, and therefore the probability that the mission would be less successful was very high. With MILS architectures, this critical information arrives faster and with more critical content that is usually locked down in the CAOC. Now, as you probably know, for offensive counter-air-to-air missions, the Air Force primarily deploys F-15s or F-22s. In this case, we're going to send our F-22s after some MiG-29s. In a fair fight? Not if we can help it. And that's where the Mills architecture is going to make the difference. So let's get going. Boeing, you guys ready? Lockheed Martin, I know you're ready. Raytheon, you're all set? All right, Rockwell College, you're all set. Okay, they're ready, so let's do it. Now right here, we're looking at the COP again, and the KOC can be seen in the Rockwell College booth right across the aisle. Looks like the KOC has picked up information from the AWACs. The MiG-29s are in the air. The AWACS passes that information to the F-22s, which in turn send the MiG targeting information to the KOC. The KOC authorizes engagement of the MiGs to the AWACS. AWACS passes that authorization to the F-22s. The F-22s confirm the identity and the positional information of the MiGs. They request permission to destroy. The AWACS confirms that they can indeed destroy the MiGs, and it also passes the engagement information back to the KOC. We can then see the F-22s engage the MiGs and fire their AMRAAM missiles. The AMRAAMs destroy the MiG targets, and the kill is recorded by the F-22s. The F-22s pass the acknowledgement of target destruction back to the AWACS, and this information is relayed back to the KOC and confirmed. End of story. So, how did Mills make this mission more effective? Well, current technologies are restricted and limited to a very narrow range of dedicated assets. But with Mills, the information about the destruction of these targets can be communicated not only to our own forces, but because a subset of this information can be classified as secret releasable, we can communicate with any coalition partners in the KOC in real time, using multi-level secure hardware systems. End result? Planning is improved by delivering more current situational information. Mission efficiency is increased because the status of enemy assets is kept current.
Okay, on to our next mission, taking us another step closer to our rescue. In this phase of our rescue mission, we get a surprise because Special Operations Forces have found a SCUD transporter erector launcher, a SCUDTEL. Special Operations, acting as forward air controllers, are typically equipped with very secure, beyond line-of-sight communications, linked back to several locations, including the KOC.
Boeing, you ready? Lockheed Martin, you ready? Raytheon, you're set to go. Rockwell Collins, are you ready? They're ready, so let's do it. Okay, here we go. The SOF sends target info to the KOC and requests that the SCUDTEL be taken out. Now, on this time-sensitive mission, the KOC transmits mission messages to a Global Hawk, to an F-18, and to a UCAV. The KOC directs the Global Hawk to take pictures of the SCUDTEL, and the Global Hawk sends its Wilco. The Global Hawk then snaps the pictures and sends them into the KOC. Now, what makes time-sensitive targeting and Mills so important here is the ability to use ISR equipment that is controlled by other services, in this case the Army. And the KOC directs the F-18 to go ahead and destroy that launcher. The F-18 in turn tasks the armed UCAV to make the hit. The UCAV says, "will do." And the F-18 forwards the UCAV Wilco to the KOC. A short time later, the UCAV destroys the SCUD launcher, as you'll see, and sends a HAVCO to the F-18, which forwards it onto the KOC. Finally, the KOC directs the Global Hawk to do a damage assessment. It Wilcos, acquires the images of the destroyed SCUDTEL, and then sends them into the KOC. Mission complete. So, in the mission you've just seen, Mills helps the TST establish priority for high-value assets based on information that can only be gained at a high classification level, and maybe from a different armed force or coalition partner. Mills-based systems enable timely distribution to the critical assets. And it does all this without the addition of separate hardware platforms to support the different secure communications domains. Okay, we now move on to our fourth and final Mills mission, which is what we've been preparing for all along. A combat search and rescue, a CSAR. Now, the most important sets of coordinates, besides those of Osama bin Laden, is the position of a downed airman in a war zone. So let's get that guy rescued. Boeing, you ready? Lockheed Martin, you're ready. Raytheon, I know both you guys are ready. And Rockwell Collins, are you ready? They're ready, so let's do it. Now, the first set of information here is an unclassified radio call from the downed airman. In code, he gives his fitness to evade and his position in relationship to pre-briefed evasion plans. Nearby, there's an F-18 that picks up the airman's radio call and forwards it to the CAOC, which tasks a Global Hawk to CSAR video imaging. The Global Hawk Wilco's flies in and records the images and transmits them to the CAOC. Next, the airman's transmission requires the fighter to end its current mission and set up a SAR combat air patrol to protect the airman, of course. The CAOC informs the fighter to switch to the CSAR mission, and he complies. Then, while on his SAR combat air patrol, the fighter pilot will send back relevant rescue information to the CAOC. Using MILS, that information is forwarded to a time-sensitive targeting cell and then on to other military assets to reestablish priorities for each of them. In this case, the CAOC tasks an HH-60 helicopter to assist the airman, and the chopper says Wilco. And by the way, the positional information that's handed off can go through a link through an airborne asset or directly through the evader's survival radio to the HH-60 Pave Hawk. Either way, the Pave Hawk gets the position and Wilco's the CAOC. It flies to the location, picks up the airman, half goes the CAOC, and everybody goes home. Mission accomplished using MILS-based communications platforms. Now, as you've just seen, in all four scenarios, the MILS environment helps top secret and secret information flow more quickly and efficiently between all assets in the field. Whereas in the past, there would have been delays and barriers to this information. We can now get the right information to the right people at the right time. And we can do it while protecting both military and intelligence communications networks on the global information grid. And we can do this without increasing the hardware platforms in these systems. If you want to find out more about the MILS architecture and how all these systems work together, we've got a lot of people here with a lot of expertise, so please step up and ask as many questions as you'd like. But first, thanks for joining us here at Wind River.